All right, a logarithm is an inverse of exponential. And we're going to find some inverses on the back of this paper. Remember switch X and Y? We did a whole unit on it. It's just a reversal. So the whole point of it is like, why on earth do we have logarithms? Why does this exist? It is a way to solve for the exponent. In other words, it isolates the exponent. It equals the exponent. I'm going to say that 4,000 times. The logarithm equals the exponent. The logarithm equals the exponent. That's the whole point. Mathematically, we had no way to isolate an exponent. Like, how do you get it down out of the power? That's what a logarithm does. That is the purpose of it. That's why, like, it exists. Inverse of an exponential. You cannot have a negative base. I went through a lovely explanation of why that is last time. You can either go rewatch it if you're interested or just trust me, but you cannot have a negative base. Do you guys remember that from last time? Sort of. Okay, but it's true. You cannot have a negative base. Now, there's two kind of special ones. The common base is 10. And so when it's the common base, we don't write it. It's just understood to be a 10. So if you just see log of x without a little base number there, it's understood to be 10. That's because we have a base 10 number system. We have 10 digits. We have, 0 and 1 through 9. Do you get what I'm saying? Like, and we recycle every 10. And then the other one is the natural base, which is E. So that one's written in a special way too. We write lnx. You don't write log base E. That's not a thing. We write ln. It's a natural logarithm. It's like log natural, though. It's ln. So like log natural. Are you coming with me on this? ln. Anyway, that's just what that means. It means that the base is that 2.718 number. So we're just going to practice today. We're not even going to do the graphs. I saved that for next time. All today is about is getting comfortable with the format, because I understand that people are like, why is this word in my math problem? Okay, logarithms are not all that hard. They just look funny. So all today is about is getting comfortable with it. So if it says write in log form, you need to write the word log. And basically, this is just about getting all the puzzle pieces in the right place. You want to do the base first. Use your common sense. Which number, the 2, the 3, or the 8, do you think is the base? 2. Good. I know this is so stupid, but I always say the base goes in the basement. It's the subscript. It goes down there. Get what I'm saying? Now you're going to, I know, I'll make an idiot out of myself to get you to remember stuff. I know that sounds so dumb, but that's where that goes. Now leave a little gap and put in equals. It equals the exponent. The log equals the exponent. That's the whole point of it. So which number, the 3 or the 8, is the exponent? 3, that's the purpose of it. That's why it exists. It equals the exponent. And so 8 has to go in that gap that you left. The way we say it is log base 2 of 8 equals 3. I'm not going to yank you in the hallway and make you take a verbal exam like you do in your language classes and whatever, but that's how it's said. Let's try another one. You're going to write the word log. What is the base? 4. Leave a gap. It equals the exponent. So what is it going to equal over here? Yep, -2. And so the 1/16 has to go in that gap that you left. If you get the base in the right spot and the exponent in the right spot, there's only one other place for the other number, right? So what do you think about this one? Log base what? 36. It's going to equal a half. That's the exponent. That's kind of the whole point. And then 6 has to go in the only remaining spot. Now, these are the two special ones, E and 10. So when you see E, you're going to write ln. That means the same thing as log base E. So you know how we wrote log base 2 and log base 4 and log base 36? The ln is this part of it. Do you get what I'm saying? Okay, so leave a little gap. It's going to equal the exponent, which is 4. I didn't leave a big enough gap because I write a little bit big. And so that 54.598 goes in the gap. Why is it a weird decimal? Because E is a weird decimal. E is 2.718. So, you know, it's going to come out funny because E is a weird number, an irrational number. I shouldn't say weird. I should use good vocabulary, right? Now this one's base 10. So you're just going to write log. You don't put the 10. If it's 10, the common log, you just don't write it. Leave a gap. It's going to equal what? 3. Good. And then that 1,000 goes right there. 10 is easy because we have a base 10 number system. Do you see how your exponent is 3 and there are 3 zeros? If your exponent was 12, there would be 12 zeros. That's how that works, right? Now we're going to do the exact same thing backwards. You do the base, you do the exponent, and then there's only one other spot for what's left. What's the base for this one? 10. It's not written. The common log. Now, watch me point to this. The log equals the exponent. So whatever this equals over here is your exponent. So that's 2. So 10 squared equals 100. These ones are a little easier to check because is that true? Is 10 squared equal to 100? Yes. I hope that if you wrote 100 to the 10th power equals 2, you would go, whoops. Do you know what I'm saying? Like, use your common sense. All right, this one, your base is 5. And then what? Squared equals 25, which is a true statement. I think it's easier to go this direction. All right, your base is 49 to the what power? 1/2 equals 7. Now, why does that make sense? Do you remember what the 1/2 power means? Square root. Good job. How would you do a cube root? What power would that be? 1/3. Good. Nice. All right, what's the base for this one? It says ln, so that means base e to the power 1.945 equals 7. And then last one, 2 to the power -3 equals 1/8. What does the negative do? Yep, flips it over. So 2 cubed is 8. We just flipped it. I'm about ready to review all of these exponent properties. We did them last time, but I'm going to, review them again to make sure we know what was going on. All right. When you multiply, you add your exponents. So for example, if you have 2 to the 4th times 2 to the 3rd, and write these down. We're going to do an example. You have to have a basic understanding of how exponents work in order to do logarithms. That's what they are, is exponents, inverse of an exponential. That would be 2 to the what? 7th. Let's try and figure that out without a calculator. We're going to count on our fingers. Ready? 2 to the 1st is 2, 4, 8, 32, 64, 128. You just keep doubling it. I'll do it again. Look, 2, 4, just keep doubling. 8, 16, 32, 64, 128. All right. If you are dividing, you subtract your exponents. So for example, if you have 5 to the 7th divided by 5 to the 4th, that's going to give you 5 to the 3rd, which is one that I said you do need to know. 125. Good job. A power to another power means that you multiply them. So for example, if you had 2 cubed to the 7th, that would give you 2 to the 21st. I'm not working that one out. That would be an absolutely outrageously large number. It would be 2 times 2 times 2 times 2 times 2, 21 times. Do you get what I'm saying? Like, oh, do you remember the penny problem we did last time and how you ended up with like millions of dollars? You like that? All right, negative exponents. So if you had something like 8 to the -2, it's going to flip it. So what would that give you? 1/64th. Good. So the answer doesn't come out negative. It just flips it. That's what the negative does. It makes it a reciprocal. Here, we'll do one. Oh, yeah. Did I do that right? Okay. For a second, I thought I messed something up. All right. Let's say you did, let's do, trying to make up something else. How about if you had 5 to the negative third? What would that one give you? Good. You do 5 cubed, which is 125, and then the negative means that you reciprocate it. You flip it over. No, it's not bad. All right, and then here are your fraction ones. So for example, if you have, I don't know, let me make one up. If you have 49 to the 1/2, what's that going to give you? Be 7. If you have 27 to the 1/3, it means cube root of 27. 3. Good. All right, and then you can add another number in there as well. So here, I'll take that one and just put a 2 in it. So say you have 27 to the 2/3. We said 27 to the 1/3 was 3. Your cube root of 27 is 3. You're just then going to square that. So 3 squared is 9 is how that works. So you do your cube root, which is 3, and then you square it and get 9. You won't see those as often. I just kind of did it because it's true. We don't really do a whole lot with that. And then last one, anything to the 0 power is 1. Very good. So go ahead and flip over. We're going to use all of those exponent rules that we just talked about to evaluate our logarithms. So here's what you have to understand. The answer is the exponent. Again, the logarithm equals the exponent. So the missing piece of the puzzle that you're looking for is the exponent, the power. That's the thing that you are looking for. And this is a drill and practice thing. So we're gonna drill this, all right? So when you look at this one, what it's asking you is 2 to what power equals 64? And I heard somebody say the answer, but I'm going to talk us all through it. We're going to count on our fingers. Ready? 2 to the first is 2. Good job. 4, 8, 16, 32, 64. So 6 is your answer. You are looking for the power. 2 to the 6th power equals 64. So looking at the next one. 81 to what power gives you 9? And it is good. Why is it a half? Because that is correct. Square root. 9 squared is 81 is how you can think of that. All right, now I would do 3 to what power gives you 27, and then just think about how you flip it. So good. 3 cubed is 27, but the negative is what flips it over. Now, what's the base on this one? Since it's not written 10, these are the easiest ones. It's just however many zeros there are. So 4. 400 would be a lot of zeros.
A big number.
All right, 17 to what power gives you 17? 1. Here's the other thing you can think of when you look at that is that the log base 17 and the 17 kind of cancel out. You can think of it that way too. All right. Oh, good. Before I could even say it, why is this one 0? Good. 12 to the 0 power is 1. And then look at this one. You have ln and you have e. Those cancel each other out. They're inverses, and your power, your exponent, is 9. So if you have ln e to the 2nd, your answer is 2. If you have ln e to the 5th, your answer is 5. Okay? Now I'm going to finish this up, but we're going to play a Quizlet game where we drill that, and we're going to play it every single day until the test. Okay? So find the inverse. You're going to switch x and y, would sure help a lot if there was a y in the problem. So go ahead and scribble that out and put y. And listen to me before we even start. If the problem is exponential, your inverse will be logarithmic. If the problem is logarithmic, your inverse will be exponential. When you get stuck, and usually when I say that, I'm just like, I'm not going to get stuck, Miss Cole. I'm a genius. No, you will. It's designed in the problem. You're going to get stuck. Okay? When you get stuck, the question you ask yourself to get unstuck is, what's the base? What's the base? I used to sing, but the more time that goes by, the older and older this song gets. But I used to always just sing that Megan Trainor song. You know what I'm talking about? Because I'm all about that. So you know what I'm talking about? Anyway, when you get stuck, the question is, what's the base? Okay, so switch X and Y. So you're gonna keep everything where it is, but just switch X and Y. Do you guys know what song I'm talking about? Okay, cool. It's kind of old now at this point. All right. Now we're not stuck yet. What can we do first? Yeah, subtract over the 1. And then you are stuck. You are trying to get y by itself, but y is the exponent. So you're stuck. So here's the question. What number in there is the base? 1/2. So you're going to write log base 1/2, leave a gap, and the whole point is that it equals the exponent. So what's the exponent? Y. And that was the whole point. You wanted y by itself. And then what goes in this gap here that we didn't use? Yeah, and you just need to give that a hug. You kind of didn't get to see. Can you wait until I do the next one? And I think you'll be all right. Now, if you write equals y, 100% full credit. But since we found an inverse, do you remember how to write an inverse? Yep, with the little -1 in there. Perfect. So when you get stuck, what's the base? For this one, scribble out f of x, put y. You're going to switch x and y. As foreshadowing, do you see how this one has e in it? That means your inverse is going to have what do you think? ln. God, top of this. All right, what would you do to both sides first? We're not stuck yet. +7, good. X plus 7 equals 2e to the y. You're still not stuck. You can actually do one more thing. Yep, divide everything by 2. And then you are stuck. So the question is, what's the base? And the base is e. And so that's why we do ln, leave a gap. And the whole point is that it equals the exponent, which is y. Instead of y, I'm going to write inverse. If you write y, that's totally fine. All right. And then what's the stuff that we didn't use that's going to go? Yeah, and just give it a hug. X plus 7 over 2. Now, these two are logarithms. That means our inverse should be exponential. You should have something exponential as your answer. All right. So scribble out f of x, call it y. We're going to switch x and y. I don't like when there's a log and a y. It looks like loggy, and that bothers me. But we'll fix it. That won't be in our answer. All right, we're not stuck yet. What can we do first? Yep, subtract 3. Now I'm stuck. What's the question? What is the base? The base is 4. The base will always be a number. Or it should be. I guess things can get weird sometimes, but it should usually be a number. All right, 4 to the power x minus 3. And you can give that a hug if you would like to. It's all in the exponents. You kind of don't need it, but there's nothing wrong with extra hugs. All right, equals y. And you can write y. That's totally fine. But we are finding an inverse, so I'm putting inverse. All right, one more. Since this one has ln, when we find our inverse, it is going to have e in it. Just foreshadowing. But you want to think about that, because most things in math, if you make an error, you can catch it because it won't make sense. All right, what first? -2. A lot of math is also recopying what you had before because you're bringing everything down to the next line with you. All right, I'm stuck. What's the base for ln? E. It's e to the power x minus 2, good, equals y plus 8. Now, this one actually has one last step. All the other ones kind of ended there. Yeah, you have to minus over the 8. So it will look like this. Why can you not combine the -2 and the -8? One's in the exponent and one is not.